No. So this is, let's see, special right triangle applications and some triangle area stuff. Okay, so the first couple should be pretty straightforward. Finding the area, so we use the area formula. 1/2 of the base times the height. So in this case, the base is 14 centimeters and the height is 6 centimeters. Pretty straightforward. Half of 14 is 7. 7 times 6 is 42 square centimeters. Okay, area equals 1/2 of base times height. Remember, the base and the height must always be perpendicular. Okay, once again, find the area. So here for this obtuse triangle, this is the height. Remember, the height and the base must be perpendicular. So 9 is the base. This much is your base. And this is the height that goes along with it, correspondingly perpendicular. So the first thing we have to do is find the height. And we will find the height by using Pythagoras. So 6 squared plus 9, 3 squared. Where did 9 come from? I must have added them together. 6 squared plus 3 squared equals height squared. And it turns out that the height is 3 roots of 3, isn't it?
Yeah.
3 roots of 3. Let's see what that is when we calculate it. 3 times the square root of 3. 3 times 3 square root. No, that's not it. Square root of 3 times 3. So 5.196 is approximately the length of this. Yes, your calculator will do 3 roots of 3. Okay, this is exactly 3 times the square root of 3. Because if you notice, here we have a hypotenuse of 6. Oh my goodness, you are correct, huh? That's no bueno. I am steering you down the wrong path. 3 squared plus h squared equals 6 squared. Lo siento mucho. So 6 is your hypotenuse. This side is 3, which means that this is going to be a 60-degree angle, because a 30, 60, 90 triangle has the relationship such that the short leg is half of the hypotenuse. Okay, so no, you do not need to know this was 60 degrees in order to figure out this is 5.196. But now that we know that's 5.196, area is equal to 1/2 of the base times the height, which is, let's see, 4.5 times 5.196. This is already 1/2 of the base, so I already halved 9. 23.382 meters squared. Meters squared. Okay, so in obtuse triangles, you might have to find the height by using the Pythagorean theorem before you can actually find the area. Remember, you have to multiply together two things that are perpendicular to find an area. Okay, classifying each triangle. We classify them as acute triangles, as right triangles, or as obtuse triangles. And we do that by applying the Pythagorean theorem. 7 squared plus 9 squared, how does that compare to 12 squared, is the question. So 49 plus 81, how does that compare to 144? Let's see, that's 50 and 80, so 130 is less than 144, which means this is an obtuse triangle. If c squared is larger than a squared plus b squared, it's an obtuse triangle. Obtuse triangle. Okay, this next one, how does 7 squared plus 24 squared compare to 25 squared? 49 plus 24 squared is 576. How does that compare to 625? That's 576, by the way. Ooh, that's even worse. Eraser. Okay, so if we add these two things together, we get 625 is equal to 625. So this must be a right triangle. Okay, let's check this last one. How does 30 squared plus 55 squared compare to 62 squared? Let's see, calculator, 30 squared plus 55 squared. That's 3925. 62 squared is probably some huge number. 3844. So this triangle is going to be acute. It is indeed an acute triangle. So obtuse, c squared is larger. Right, they are equal. If c squared is smaller, it is acute. So that's how we classify them, by applying the Pythagorean theorem. Okay, and here are your applications. An isosceles right triangle has an area of 60 square feet. So what we need to know about isosceles right triangles is you have two equal legs. Isosceles right triangles. Both of these are the same. So if we apply our area formula, area equals 1/2 of x times x. Since your base and the height are the same, you come out with this as your formula. This is only true with isosceles right triangles. Isosceles right triangles. Okay, also 45, 45, 90s. So let's see, solving for this, let's multiply both sides by 2 to get rid of the 1/2. 2 times 1, let's see, that's 120 equals x squared. And how do we solve a square? Square root both sides. So let's see, go to our calculator. 120 square roots, approximately 10.954. Okay, so if we want the hypotenuse, we will do 10.954 squared plus 10.954 squared equals c squared. So let's do that. 10.954 squared is, of course, 120. So 120 plus 120 is, 240. So 240 equals c squared. So what is the square root of 240? 15.492 is the approximate length of the hypotenuse. Okay, so it says approximate here. I don't know if it says approximate on your paper, but the approximate length of the hypotenuse can be decimalized. So remember, isosceles right triangles. The two legs are the same, so your area formula equals area equals 1/2 of x times x. And you get an x squared, which you can easily solve. Okay, a triangle has a height that is 10 units more than the base. So height equals base plus 10. Base plus 10. So area equals 1/2 of base times height. So the base is just b, and the height is b plus 10. Okay, so we substitute height for its related value over here, b plus 10. Okay, so we're going to solve this equation right here. So let's see, times both sides by 2 to get rid of the 1/2. I will distribute my b's on that side. So let's see, 96 equals b squared plus 10b. Okay, so there are many ways that we can solve this. One way is by using your graphing calculator. Let's find our graphing calculator. Here it is. Okay, remember, we're going to go into our y equals and put in our equations. Well, just this equation, basically. We're going to put in x squared plus 10x. Uh-oh, I can't see my 0. No help. Plus 10x. Okay, that's your equation, x squared plus 10x, and we're going to look in our table for the value 96. It looks like we have it right there. So here we have a y value of 96 when we have an x value of 6. So that means b equals 6. Awesome, we have a base of 6 units, which means we have a height of 16 units, just to be sure. Okay, so make sure you are filling in all the information that you are asked for. Here we want the base and the height. One is 6, one is 16. So when we have a quadratic, you can solve it by using the y equals button on your calculator. It's a very nice, easy way to do it, especially when it's got pretty numbers and it is factorable. So here we have a base of a triangle is 6 times the height. 6 times the height, so 6 h's here. If the area is 92 equals 1/2 of 6h times h. Okay, in this case I am substituting my base so that I only have a variable of h, and I can find the height using this problem here. So in this case I'm going to do all of this together, 1/2 times 6 times h, rather than multiplying both sides times 2. 3h squared. Half of 6 is 3, h times h is h squared.
How do you know until like multiply it by 2 or do the whole thing together?
The easiest way, if you have half of an even number, so this 6 is an even number, taking half of that is very easy to do. There is no pluses or minuses over here, so you don't have to distribute the 1/2 like we had over here. So here we had a plus, rather than having half of b squared, a fraction right there, I would rather just multiply by 2 and get rid of it. Okay, it would have been fine to do that here and get 184 equals 6h squared. Either way, we would have gotten the same answer. But this one we solve just by using algebra. So we divide both sides by 3. Make sure you always divide first whenever we have a product with a square. This goes into here 30 and 2/3 times 6, 6, 6, 6, 6, 6, 6, 6, 6, if you like. And how do we solve a square? We square root it. So let's see the approximate square roots. Let's do this in the calculator. 92 divided by 3 is 30.666667. Let's take the square root of that, and that gives us 5.538. Okay, fantastic, but it asked for the base, so we have to multiply this by 6. So over here in the calculator, times 6, 33.22, we'll go with 7 just for funsies, units. Got that one way wrong? We'll now get it way right tomorrow. Okay, so use the formula to solve for h. We have an area, so we use an area formula. Solve all the way down till you get to regular h. Okay, this one is different because it doesn't have a plus or a minus. It's not a quadratic, it's just a square. So we solve squares by dividing first, divide by the coefficient, and then square root last. Okay, always try, if possible, to square root last. Okay, an isosceles triangle with a height of 14 and an area of 168 has a perimeter of what? So here's our isosceles triangle. Not an isosceles right triangle, just an isosceles triangle. Has a height of 14. So when we apply the area formula, 168 equals half of our base times 14, we will find this entire length down here, B. Okay, so let's see. Want to multiply or you want to divide? Okay, so what's half of 14? 7. So dividing both sides by 7, B is 24. So the whole entire base is 24 units long. Okay, but what we want to do is now figure out what this length is here. Okay, so if our entire base is 14, that means this height bisects it into two different lengths. Okay, into two equal lengths. The entire base is 24, so both of these are 12. So right here I have myself what kind of a triangle? Just a right triangle. So I can do 14 squared plus 12 squared equals c squared. Okay? This will allow me to find what my hypotenuse of this right triangle is, and it's also one of the legs of my isosceles triangle. So let's see, let's come over here. 14 squared. No, not square root. Sorry. Get rid of that. 14 squared plus 12 squared equals. I don't think that's right. What do you think?
You're adding 12 and then square.
14 squared is 196 plus 144. Okay, 340. That's the sum of 14 squared and 12 squared. And now square rooting 340, our hypotenuse is about 18.439. Okay, so perimeter is the sum of all the sides. 18.439 plus 18.439 plus 24. Go back to our calculator. Times 2 plus 24. We have a perimeter of 60.878 millimeters. Okay, so remember the difference between an isosceles triangle and an isosceles right triangle. So with isosceles triangles, we just have this much. An equilateral triangle with a perimeter of 36 has an exact area of what? Okay, so here we have our equilateral triangle that has 60-degree angles everywhere. And if it has a perimeter of 36, that means all the sides are 12. So if I want area, I need to figure out what the height of this triangle is. Okay? So this is a special right triangle, 30, 60, 90. So this much is 6, and it has a height of 6 root 3. Okay, the 30, 60, 90 relationship allows us to find this long leg of our 30, 60, 90. So area is 1/2 of the base, which is 12, times the height of 6 roots of 3. So this is going to be an exact answer. We're not going to put this into our calculator and get a decimal approximation. So 1/2 of 12 is 6. 6 times 6 is 36 roots of 3 square feet. Okay, this is the exact answer. It has a radical in it. If it wanted the approximation, then you could have decimalized it. Okay? But always for an equilateral triangle, you break the height down and you have a special right, a 30, 60, 90, where this always bisects your base, and this is the long leg of a 30, 60, 90. Okay? Always with equilateral triangles. A square with a diagonal of 6 roots of 10 has an area of what? So this is a special 45, 45, 90 triangle. Okay, and the hypotenuse is something times the square root of 2. Okay, so if I had 6 roots of 10, and that was something times the square root of 2, that means I'm going to have a leg of 6 roots of 5. So the area for my square is 6 roots of 5, which is the leg, squared. So I distribute the square, because I don't have a plus. 36 times 5 is 180 square yards. Okay, remember the hypotenuse is the leg times the square root of 2. So this is going to be your leg length, 6 roots of 5, because this times this is 6 roots of 10. Okay, and our last one is a Pythagorean theorem problem. Remember, this is x.
Excuse me.
No excuse.
Students, I have
If this is 20 feet,
for the seniors today, we have
that means this is 52 minus x. Okay, the whole height was 52. It broke x units up, so this much is 52 minus x. X squared plus 20 squared is equal to 52 minus x squared. Okay, and this Pythagorean theorem is what you solve. Remember, you get 3 terms over here. You get a 52 squared term. You get a 104x term from twice 52, and we get an x squared term. Okay, you get 3 terms when you square a binomial. 52 squared, you double the product here. So twice 52 is 104, and you get x squared. Okay, so some things end up canceling out here. Well, minus 52 squared from both sides. Minus x squared. Oh, let's see, what is 20 squared minus 52 squared? Minus 2684. Negative 104. Divide both sides by negative 104. And we get approximately 25 feet up. 25.8 is how high the crack was up there. Okay? The answers to the review will be on my outreach page. So the Google Sites Brandeis has. You can go to my page, but it's the Geometry Pre-AP page is where you're going to find the answers to the review.